Okay, next topic is something called relations. And relations are things where you relate um, two variables, or they're showing the relationship between two things that change. Or another way to look at it is a relation to look at what is the connection between two things. One of the things would be an output, the other would be an input. You might have done these in elementary school where you have an input and output machine. You put a certain variable into the machine, an input, and then you get a certain value that comes out of it based on that. Alright, let me just show you a video. Before we do that, again, to find the output based on the input, there's a few things we could do. We can either write an equation using algebra language tricks, make a table, or make a graph. If you want to know what is the connection between an input and an output. Now you might be thinking, well, what is an input and output? Well, let me show you this little video here, and so sit tight. It's about a minute long. Take a watch. Okay, you get the idea. Input, output. In this case, here we have cows being the input, the output, steak fingers. And the example that they showed you before, we have the little chickens going to the slaughterhouse, and you saw what happened. The little chickens turned into nuggets. So, let's take a look at the first example here of a relationship between chickens and nuggets. Let's say that one chicken makes 12 chicken nuggets. What are our two variables? What's our two things that we're connecting here? The two things, the two variables. Well, one would be chicken. There's a certain amount of chickens that went in. So chicken, or chickens, would be one of the variables. The other variable would be what comes out, the nuggets. So, we can say, of these two variables, the chickens would be the input because they are what you put into this system. And the nuggets would be the output because they are what you get out of the system. Make sense? And then for the second one, they had cows and steak fingers. The cows were the input, and the steak fingers were the output. Now, to figure out how many nuggets can be made, you can make an equation. So, let's take what we know. Since each chicken makes 12 nuggets, how could you write that as an equation? Each chicken makes 12 nuggets. So to figure out how many nuggets you have, to get the number of nuggets, you're going to take every chicken is worth 12 nuggets. So what you're going to do is 12 times the number of chickens you have. This is the formula to get the number of nuggets that you need. So this is this translated. We can rewrite this a different way. Instead of writing nuggets and chickens, we can call nuggets some letter, some variable. Let's call it n for nuggets. 12 is there, and chickens, just call it c. No one does the times anymore, just put 12c like this. So this would be our formula, or if you want, you can use this if you like, if you got spare time, like to write out long words. This is our formula for the nuggets and the chickens. Okay, so here's a typical question you might get. You can use the equation or just simple common sense and fill in this table for up to 5 chickens and find out how many nuggets they can make. Okay, so here's what we call a table of values. And using the table of values, the input is on the left side and the output is on the right side. So here we have up to 5 chickens. How many nuggets will we make? Well, there's 2 ways to do this. Like we said, common sense or using the equation. Common sense tells you for every chicken, this is saying for every chicken we make 12 nuggets. So common sense will say if you had 0 chickens, you would make 0 nuggets. 1 chicken would be 12 nuggets. And you go on and on. That's what common sense would tell you, and you can use that. Go ahead, fill the table in and get the answer. If you didn't have common sense, or you didn't want to use common sense and you wanted to use the equation, well, let's use the equation. N equals 12c. What we're going to do is we're going to, one by one, put these inputs into this machine, this input-output machine, and see how many chickens, how many nuggets we get out. So for 0 chickens, what we would find is we would sub 0 in for the C chickens. N equals 12 times 0. 12 times 0 obviously is 0. So for 0 chickens, we would get N 0 nuggets. Then let's try it for 1 chicken. For 1 chicken, we'll abbreviate with a C. We can call it N equals 12 times C. N equals, when we sub in the 1 in the brackets like that, 12 times 1 is 12. So for 1 chicken, we get 12 nuggets. Then for 2 chickens, you just go N equals 12, N equals 12 times 2. I'm not going to write the formula out this time, and just go right there, which is 24. Now, at this point, as long as there's a pattern here, you can see a pattern developing here. What are we going up by in each case? We're going up by 12. So there's no need to do all that work for the rest of the table. When you see a pattern, fill it in. So for the rest of it, look for the pattern. And I would do 3 of them first before you see a pattern. We're going up by 12. So obviously this one will be 36. And then after 36, you get 48. And then after that, you would get 60. So there is our table. 5 chickens would make 60 nuggets, and there's the rest of them for the number of chickens and nuggets you would get. Okay, now here's some other questions. How many nuggets will you get from 11 chickens? Again, you could use common sense, or you could use the formula. The formula, again, that we had here was nuggets equals 12 times chickens. How many nuggets will you get from 11 chickens? Well, we can sub in 11 in for chickens, so nuggets equals 12 times 11 chickens, and you have to go 12 times 11, which is 132. Trust me, it is. So 11 chickens will give us 132 nuggets. What about a question like this? If you need 55 nuggets for a family picnic, how many chickens will you need? So far, the questions we've done, you're probably thinking, what's this whole formula thing? I can just do it in my head. Good for you if you can. I'm letting you do it in your head without using the formula. This one you might need to use the formula. Again, our formula is, for this chickens and nuggets thing, 12 nuggets is 12 chickens, 12 times chickens. We're told we have 55 nuggets, so we're going to put 55 in for nuggets. 55 is what we're subbing in. Don't have to put it in brackets, but we'll do it anyway, just to be consistent. 12C. I want to figure out how many chickens we're going to need. Well, there's the C. We want to get it by itself. What's bugging it? The 12. 12 is multiplying it. Divide by 12. Do the same to the other side. These are gone. The number of chickens that you're going to need, 55 divided by 12, which is 4.58 chickens. If you're wondering, how can you get 4.58 chickens? Well, you saw those sharp blades that they use to cut the chickens up. I'm sure they could figure it out. Okay, here's the next question. Enough of the chickens and the nuggets. Let's talk about pizza. Let's say the cost for a pizza at Sam's Pizza Shack is $12 for a large, and then they charge $2 for each additional topping. Okay, so what are the variables? What's going to change here? Well, things that are going to change are cost, how much it's going to cost for your pizza, and the toppings. So our variable is cost, and the other variable is toppings. Now some might say, well, wouldn't pizza be a variable as well, because you could buy 1 or 2 or 3 pizzas? No, not in this case. Let's just make it simple and say that Sam's Pizza Shack only sells, the maximum number of pizzas you can buy at Sam's Pizza Shack is 1. But you can put as many toppings as you want on it. It's weird, I know, just go with it. So those are our 2 variables. What would the input be in this little situation here? The input is toppings. Because it's the number of toppings that we order or we suggest, that's going to spit out what our cost is. So we, based on the number of toppings, we'll get our output, which is the cost in dollars. What's the equation going to be? Okay, so the cost for a pizza is, so cost is, remember that's equal sign, $12 for a large, $12 flat for a large pizza, and then plus 2 for each topping, $2 for each topping. So that's 2 times the number of toppings that you're gonna add on to your pizza. That's the wordy equation. We want to simplify it into symbols. This variable we can call cost, C for cost, equals 12 plus 2. What variable should we pick for toppings? Why not T? I make a little fancy handwriting T to make it look different than the plus sign. So there's the formula we're going to use. This is the formula for number of pizzas. Okay, fill in the table using whatever method you like. I'll stick with the formula method just because that's the one that people are going to have more trouble with. If you already know the common sense, you can fill this table in, go right ahead. I don't care how you get it, just fill the table in. So if we're going to do this using the formula, we look at the number of toppings. So for 1 topping, we would sub in 1 in for toppings, and we figured out how much cost it's going to be. C equals 12 plus 2 times 1. Bed mass, 2 times 1 we do first, the multiplying first is 2 plus 12. 2 plus 12 is 14. So our cost for 1 pizza with 1 topping is $14. Let's try for 2. For 2 toppings, cost equals 12 plus 2 times 2, because there's 2 toppings. That's 2 times 2, we do the bed mass. Multiplying first is 4 plus 12, and 12 plus 4 is 16. So our cost for 2 toppings would be 16. Let's try another one just to make sure that we got this right. For 3, we would go cost equals 12 plus 2 toppings, 12 plus 2 times 3, 2 times 3 is 6, plus 12, that's 18, so our cost will be 18 for 3 toppings. Again, once you've done 3, you've got a good idea what the pattern is. You don't have to do the rest. We're going up by 2, going up by 2, this one's probably going up by 2 as well, so that's 20, and that's 22. And you can only do this little pattern trick if these numbers, your inputs, are also going up by a certain pattern. There's a pattern here, then you can use a pattern over here. If it was some random numbers here, then you would have to actually do the workings out for those last two. So there's our cost table for the number of toppings that we'd get on a pizza. Alright, what if we have some specific questions like this? If I've got $19, how many toppings could I get on my pizza? Here's our formula. Cost equals 12 plus 2t. $19. That is the what? What are we going to sub that in for? Cost or toppings? It's cost. So $19. Fill everything else in. We don't know t. We're looking for t. We're looking for how many toppings. So we want to get the t by itself. Reverse BEDMAS here. Remember when you do algebra, reverse BEDMAS? Subtract 12. Subtract 12. 19 minus 12 is 7. These 12s go away. You're left with 2t. 2 times t. Get rid of 2 by dividing by 2. Divide by 2. The 2's cancel out. And you're left with t equals 7 divided by 2, which, trust me, is 3.5. So, with your $19, you can get 3.5 toppings. I'm not really sure what 3.5 toppings would look like, but you get the idea. Alright, if I wanted a large pizza with 7 toppings, what would it cost? C equals 12 plus 2t. That's the formula we figured out. 7 toppings. Let's sub in 7 into here. So cost equals 12 plus 2 times 7. BEDMAS, multiplying first. 2 times 7 is 14 plus 12. When you do that, you get $26. Our cost is going to be $26 for a large pizza with 7 toppings. There we are. Okay, last example I'm going to give you. This is a goofy one. Let's say that we could figure out a formula for the temperature in February. This is made up, by the way. A temperature for the February, it was given by this. Let's say the temperature of the next day in February. You can predict the temperature of the next day is always this. It's always 3 degrees higher than twice the current day's high temperature. So like if the current day, today, had a certain temperature, what we would do with it is double it, twice it, and add 3, and according to this formula you would get the temperature of the next day. So our variables are, the things that are going to change are the temperature of the next day and the current day's temperature. So we'll just put that, temperature of the next day, and the current day's high temperature is the other variable. What's the input? What depends on what? Does the next day's temperature depend on the current day temperature? Or does the current day temperature depend on the next day's temperature? What we're putting in is the current day. So the current day's temperature is going to be the input. And the output is what we get out, what we'll figure out, which is going to be the next day's temperature. Okay, let's translate this little thing into algebra language. The temperature of the next day in February is temperature of the next day in February. I don't want to write all that stuff up. Let's just write next day. So find out the temperature of the following day, the next day, that is equal to, or is, always, is means equals, is means equals, 3 degrees higher, so 3 degrees higher means plus, twice the current day. Twice means 2 times. 2 times the current day. Okay, It's a lot of words. Let's pick a one letter to represent next day. Let's pick N. 3 plus 2 times C for current day. There's our formula. Alright. Made a little mistake here. That's supposed to be -2. That's a -1. That's a +1. And that's a +2. So if you can make that change, if it hasn't already been changed on your sheet. Okay, so fill in the table using any method you wish. Now there's negative signs here because it's cold in February, so be careful. You might want to actually not rely on common sense and use a formula instead. So for our first number, -2, for -2, let's plug this into here. N equals 3 plus 2C. So the current day temperature of -2, let's plug it into here. N equals 3 plus 2, and whatever you're subbing in, this is the whole point why we put it in brackets for this right here. Just keep it tidy. Because some of you, when you don't put the brackets in, you end up saying it's 22. Don't be sloppy. Whatever you're subbing in, put in brackets. And use bed mass. 2 times -2 is -4. Bring down the 3. Now you could bring down the 3 and the plus, but you know that when you have a plus and a minus, you're going to get a minus anyways, so let's just call it bring down the 3. 3 minus 4 is -1. So current temperature of -2, we sub it in, we get next day's temperature of -1. Let's try that for the next one, which is the current day's temperature being -1. N equals 3 plus 2C. N equals 3 plus 2 times what we're subbing in, -1. Do that first. 2 times -1 is -2. Bring down the 3. And that gives you 1. So when it's -1, the current temperature, or sorry, when the current temperature is 1, next day it'll be 1 degree. Again, let's do at least 3 so we see a pattern. For 0, N equals 3 plus 2C. We'll sub a 0 into here. 3 plus 2 times 0. 2 times 0 is 0 plus 3. N equals 3. So when it's 0, it's 3 degrees. Okay, so there's a pattern here, -2, 1, 0, 1, 2. What's the pattern here? We're going up by how much? From -1, 0, 1, that's skipping it by 2. And 1 to 3, we're going up by 2. So the pattern here is we're going up by 2's. So this one's probably going to be 5, and that one's going to be 7. Okay, so here's some word problems. If the current day's temperature is -5 degrees, what will the next day's temperature be? Let's use our formula. N equals 3 plus 2C. The current day's temperature is -5 degrees, so we'll put -5 into here. So N equals 3 plus 2 times -5. Put it in brackets. Whatever you're subbing in, put it in brackets. 2 times -5 is -10. Bring down the 3. 3 minus 10 is -7. So the next day's temperature would be -7 based on our little formula here. Okay, now if we find the temperature somehow of the next day and we find out that it ends up being 12 degrees, the temperature of the next day was 12 degrees. What was the temperature for the day before? Here's the formula again. The next day temperature was 12 degrees. Next day 12, and for next day we'll put a 12 right here. Put it in brackets. And then we don't know the day before. I mean, the next day is 12, and the day before makes it the current day, right? So we need to solve for C. Well, what's bugging C? That is, and that is. Reverse bed mass, get rid of the thing it's adding. Subtract 3, you get 9. These are gone, you get 2C. The 2 is multiplying the C, it's bugging it, so we're going to divide by 2, divide by 2. The 2's cancel out. 9 divided by 2 is 4.5. That's your current day's temperature, 4.5 degrees. Degree sign Celsius too for all those. So 4.5 degrees Celsius. Here's your skill testing questions. Talking about Bob working at the gas station. I gave you the formula for this, so you don't have to figure it out because it is tricky to get it on your own. And a diet plan that a child goes on. Now this, since I've given you the notes typed up, you don't have to worry about writing it all out. It's already there. That's the end of the video. Talk to you later. Bye.